Okay, guys, I welcome you to today's focus in trying to revise for the exam. This is going to be a series of 2024 Statistics 1, October, November statistics variant papers. Then we'll look at February, March, and May, June. Look out for this series of revision videos, as they are going to help you so much in terms of you understanding how to answer exam questions in statistics, which is probability and statistics paper 5. So the first series is going to tackle October, November 2024, and this is going to be variant 1. Now, I've written here that my focus questions will be on binomial and geometric distribution, further probability, and permutation and combinations, as these are some of the topics that have been requested of late by most of you. So I thought maybe we should spend more time trying to look at how we can answer these questions. So in this paper and in this series, we are just going to look at questions to do with binomial, geometric distribution, further probability, and permutation and combination. So let's straight away look at questions. Now there's this question 1 here, okay? It says Nicola throws an ordinary fair 6-sided dice. The random variable x is the number of throws that she takes to obtain a 6. Now it is important to take note of keywords. They've said fair 6-sided die. Now if they say fair 6-sided die, they mean each number on that die has equal chances of being obtained, and we've got 6 numbers, meaning each number has a 1 out of 6 chance of showing up. Now they've actually given us what number of concern or interest we are looking at. They are saying the random variable we are interested in is when we roll a 6, okay, or when we throw a 6, sorry. So now a 6 is our probability of success. Now this should mean our p in this case is 1/6. And when we obtain any other number other than a 6, that should be considered as failure, which is 5/6. Now the biggest question that comes in is, which part of binomial and geometric question is this? Is this a binomial or a geometric distribution? Now I'm going to give you a vague or just a simple explanation. In our notes, and when we looked at binomial, we said binomial distribution, this is where you've got a fixed number of attempts and you are looking at how many times you are successful in that fixed number of attempts. For a geometric distribution, we said the geometric distribution looks at when you attain success and the number of attempts is not fixed. I'm going to say that again. Binomial distribution has a fixed number of attempts, and in that fixed number of attempts you are looking at how many successes you are going to have. If the question is geometric, a geometric question does not have a fixed number of attempts, and it only looks at when you attain success. That is very important for us to remember. Now, if we read this question, they are saying find the probability that a 6 is obtained in less than 8 throws. Now, if you look at this, we haven't been given how many number of throws we must be throwing and then looking at when we attain a 6. They've just said find the probability that we are successful in less than 8 throws. So it's open. We haven't been told that we are doing this experiment in maybe 10, 20, 30 attempts. No, it's still open. So the fact that this is open, it means this is a geometric distribution. And then I'm reminded in the notes you have that the probability of attaining success, okay, in less than r attempts, if you remember, this we said is equal to the formula 1 minus q and then r minus 1. This is what we said. Very important to remember when we look at geometric distribution and we are looking at when we attain success. If we are to attain success in less than r attempts, the formula that we have in our notes and that we looked at is this one. So this is the formula that fits this question. They said find the probability that we are successful in 8 attempts, in less than 8 attempts. So our R is actually 8. Very important to note that. So all we just need to do here is apply this formula. So we are going to say this is 1 minus Q stands for the probability of failure, 5 over 6. And then this should be raised to 8 minus 1 as the formula depicts. So it is important. Then when we do this, we are going to find that 5 over 6, and then this raised to the power of 7. Okay, so we see that to the power of 7. So let's say 5 over 6, then we raise this to the power of 7. Okay, so 5 over 6 to the power of 7, then 1 minus our answer. So this means this probability is 0.72. This is our answer. So one thing that is important is that when you notice that it's a geometric question, it is important now to ask yourself, what formulas have we looked at and what scenarios do we have? So on a geometric distribution, we actually said the probability of attaining success in less than R attempts is given by this formula, which we must have in our notes, and that's it. So this part of the question is geometric. Why? Because it's on an open-ended number of trials. Now let's look at question number B. Number B is a very nice question. They say find the probability that Nicola obtains a 6. Remember, I'm told that this person on the 8th throw is going to attain a 6. Now one thing that we know is that the probability of success, which is the probability of attaining a 6, is 1 over 6. And then the probability of not obtaining a 6 is 5 over 6. Now they are telling us that in 8 throws, this person attains the second 6 on the 8th throw. So find the probability. So the best way I would want to do this, because this may come in different ways, but the concept stays the same way. Let's assume we've got 1, 2, 3, 4, 5, 6, 7, 8, and they tell us that on this 8th throw there is a 6 that comes. What's the probability here of obtaining a 6? This is 1 over 6. Now they are saying the second time, so this is the second time we obtain a 6. Second 6 here. Now it means on these other attempts here, which how many in total? 7 attempts. How many times must we have 7 attempts? How many times must we have a 6? 1. 7 attempts, we need to have to be successful 1 time. Now, but just by nature of doing this question like this, what sort of distribution is this? It means in the 7 attempts here, before the 8th time, we're successive 1 time. So 7 attempts, I'm going to write this because this is a revision. 7 attempts, 7 attempts, we are successive 1 time. And right away, if you've been paying attention to binomial and geometric distribution, this part is a binomial. It means on 7 attempts you are successful 1 time. So from the way we did binomial, we're going to say this is 7 choose 1, and then the probability of success, which is 1 over 6, over 1, times 5 over 6. Remember the question goes 7 minus 1, then this times the 8th attempt, which is this guy here, which is 1 over 6. So now here we just need to check out 7 choose 1 is 7 times 1 over 6 times 5 over 6 to the power of 6 times again 1 over 6, which is the 8th attempt, okay, where we obtain a 6. So if we do this, we just need to punch on our calculator again. It means the answer to this question is 0.0651 to 3 significant figures. So it's very important to actually understand the question and how the condition that is given can be met. Remember, when we started here, we started with this question being geometric because we were not given a fixed number of attempts. This is why I always talk about geometric and binomial. So geometric, okay, geometric has no fixed number of attempts, has no fixed number of attempts, okay. I'm just going to write that. Has no fixed number of attempts, which is why this question was important, because we said we obtain a 6 in less than 8 throws. So 8 is not like a fixed number of throws, no. It's just telling us in what time frame or attempt frame we should be successful, okay. And then for the second part here, with the condition of saying there's a second 6 that turns out on the 8th throw here, which is 1 over 6 on that throw. It means now from the 1st to the 7th, we've got a fixed number of attempts there, and we must only be successful one time, so that the 8th throw can be a second success time, which changes the question to binomial, because for the first 7 throws, we must only be successful one time. Now, this 7 makes it to be a fixed number of attempts, gives us a fixed number, okay. And once we have a fixed number of attempts, then we know we are dealing with a binomial distribution. And then our focus for today, yeah, there is a question number 4, which is further probability. Yes, okay. So let's look at this question and see what we need to do for that. Now, question number 4 here is on further probability, and a very nice question. So there is a person, Rahul, who has 2 bags X and Y. Bag X contains 4 red marbles and 2 blue balls. So I love to sometimes simplify this. I'm going to write this that X, okay, has 4 red and then 2 blue. Okay, very important. And then bag Y contains, so then I've got the Y bag, which contains 3 red, okay, and 4 blue. So then 4 blue there. So we've got 2 bags X and Y, okay, 2 bags X and Y. Now, Rahul also has a coin which is biased, so that the probability of obtaining head when it is thrown is 1 over 4. Biased means there are no equal chances of obtaining head and tails. So we've got a coin where the probability of getting head and tail, okay, the probability here are biased. So the probability of obtaining head is 1 over 4. Then the other one meaning is 3 over 4. Now let's play this game of statistics and see what they want us to do. Okay, so I'm just going to make this a bit smaller to have space. Now they are saying Rao throws the coin. If he obtains head, okay, he chooses at random a marble from bag X, okay. He notes the color and replaces that, okay. I'm going to underline that. And then he chooses at random a second marble from bag X. So if this person throws the coin and obtains head, he's going to choose 2 marbles from bag X. He will pick the first one, notes the color, and then retains that in the bag, and picks the second one and then notes the color, okay. Now if he obtains a tail, he chooses at random a bag from bag Y. So meaning head goes in bag X and then Y goes for bag tail goes for bag Y. He notes the color and discards. To discard in probability means no replacement. Okay, so I'm going to write that. No replacement. So this simply means we are going to touch bag X only when we've obtained heads. And then we are going to touch or choose from bag Y only when we obtain tails. All right. So the first probability as to what we pick, either bag Y or whatever that is, has to do with what we've got for heads or tails. So now here we need to come up with a tree diagram. Okay. So now we've got a tree diagram for X and Y. So I'm going to just put it over here. So this is going to be bag X, and then this is going to be bag Y. Now, what's the probability of picking from bag X? Or what's the probability of actually choosing bag X? In the normal world, this was going to be half-half. You can either pick from X or Y. But here, this toss of a coin is changing the narrative around that, because we are not looking at these bags with the same probability. We are being told that we consider what's in bag X when we get heads. And heads have got a probability of 1/4. So we've got a quarter chance of picking balls from bag X, and then a 3/4 chance of picking balls in bag Y. Okay, now remember, when we choose bag X, we are going to look at the first pick. Okay, remember we've got 4 red balls. Okay, so this is going to be red, and that is going to be blue. So red has 4 out of 7 chances, no, 4 out of 6 chances. Okay, since total number of balls in X is that. And then blue has 2 out of 6. You can simplify these probabilities if you want, but you are not going to be penalized for that. Now they say in bag X, whenever the first pick is done, so I'm going to put first pick here. Okay, he replaces, meaning for the second pick of the ball, since we are told that he's going to pick again, the probabilities are going to stay the same. Okay, so again, the probability of picking the second ball, since he replaced the first one, would stay the same, 4/6. And then for this one, it is still going to stay 2/6. And then here again, if it's going to be the same, red, blue. So here it is going to be again 4/6, 2/6. That's how it's going to go. This is now the second pick. I'm going to write that here, second pick. Very important. So now what we are going to do, let me actually try to extend this so that I have space. So this is for X, and then here we are going to have Y. Okay, so let's have Y nicely here. So that is bag X, and then here we are going to have bag Y. Remember, this is 1/4, and then this is 3/4. Now when we pick of bag Y, the probability of getting the first red ball in the first pick, so I'm going to put first here. Okay, in bag Y we've got 3 red balls, so it's going to be 3/7, since we've got 3 red balls and 4 blue balls. And then the blue balls are going to be 4/7. Now remember, if he picks, he discards. It means when I come back to pick my second pick in bag Y, I'm going to have 6 balls. Okay, so I'm going to write this red and then blue like that. So now if I picked red now in the first pick and I discarded that, it means I've got 2 red balls remaining out of 6. And then here for the blue balls, I'm still going to have the same number, since the first one I picked is not a blue one. So I'm just going to have 4 out of 6. Okay, I'm going to create that space here. And then when we come to this root here of blue, okay, if in the first pick we picked the blue ball, okay, and discarded that, it means on the second turn, we are still going to have 3 red balls out of 6 remaining, since we discarded 1. Remember the question there? And then for the second blue ball, we discarded 1 blue ball here, meaning out of 4, we now have 3 out of 6 remaining of the blue balls. So this is the tree diagram that we have. Okay, now we need to go back to the question, because this is not part of the solution. It's just part of, it's not the answer to the question. So they say find the probability that the 2 marbles that Rahul chooses are the same color. Same color means in the first you pick red or blue or whatever. Now before you choose the red or blue, there is a probability of 1/4. Okay, so we are going to say red means 1/4 times this times that. So here we've got red, okay, then we've got because we are just looking at same color here, then we've got blue. Remember, all these, they go with the probability of 1/4 since they are coming from bag X, 1/4. Okay, and then here we've got red, which goes with 3/4 chance, this guy here. And then we've got a blue here, which goes with again 3/4 of choosing bag Y. And then we've got blue. So the answer to this is when we add these probabilities here, that would give us the answer to the first part A. Now red in the first part means 1/4 times the probability of picking red, 4/6, okay, times 4/6, whatever that is going to give us. So we can actually do that, 4/6 times, so just using the calculator, 4/6 times 1/4 of choosing the X bag. So this gives me 1/9 this side. Okay, then for this one I'm going to have a 1/4 times blue means 2/6 times 2/6. Okay, whatever that is going to give me, I'm going to have 1/4 times, just using your calculator, times 2/6 times again 2/6, and then we note that, which is going to give us 1/36. So this gives me 1/36. And we move on to bag Y now. Here we are going to have 3/4 times red, 3/7 and 2/6, 3/7 times 2/6. What does this give us? So I'm just going to go back there again, 3/4 times 3/7 times 2/6. This gives me 3/28. Okay, then here we've got BB, but it's coming from bag Y, which has probability of 3/4. So this means 3/4 times B is 4/7, and then times 3/6. What this gives us? So I'm going to do that again. 3/4 times 4/7 times 3/6, which gives us 3/14. Now these are all the probabilities that do give us the same 2 colors being picked. So these are the probabilities that give us the probability of picking 2 of the same colors. Okay, so now the answer to this is simply the sum of these probabilities. So the answer to this, where we are having the probability of picking the same color, okay, same color, is simply going to be the sum of these. So I'm just going to punch that on my calculator. 1/9 plus 1/36 plus 3 over 28 plus 3 over 14, which should give us, so now this is plus 3 over 28, okay, plus 1 over 36 plus 1 over 9. So the answer gives us 29 over 63, which if you want you can write as a decimal to give you 0.460 to 3 significant figures. So this is how we answer this question here. So you can see that in this question I preferred to use a tree diagram because a tree diagram is just much easier for me to use. Some people may choose to just write these probabilities because it's easier, but I love following through the tree diagram because it reminds me and makes me check the previous probabilities if there was replacement and there was no replacement. So this is part A. Let's look at part B and see what part B is. Okay. Now part B says find the probability that the 2 marbles that Rahul chooses are both from bag Y, given that both marbles are blue. Find the probability that the 2 marbles that Rahul chooses are both from bag Y, given that they are both blue. So given in statistics, if you remember when we started, given is a condition. This is conditional probability. And let's remind ourselves of what are we being asked. So since they are saying find the probability that the 2 marbles picked are both from bag Y. So this is the probability. So I'm going to write that now here. This is the probability that the ball is from Y, given, that's how we say given that this ball is of the blue color. Okay. Now if you remember, this means the probability that the ball is from bag Y and its intersection is actually blue. Okay. So we are looking at then over the condition probability that the balls are all blue. Okay, so the condition is that the 2 balls are blue. So probability that the chosen balls are from bag Y given they are blue means probability of Y intersection blue blue, and then over the condition that is given. This is how we did the notes. And then here it's very easy to actually find this. So we are going to look for color blue blue from bag Y, which would stand for Y intersection blue. So this is what we need to do here. So we're just going to go back and pick from our tree diagram which 2 balls were from bag Y. What are those probabilities in bag Y? So you can see from here that this is bag Y, and if the probabilities are blue, this is their probability. So 3 over 14 is the probability that the balls are from bag Y and they are blue. That's blue blue. So 3 over 14. So here it means we are going to write up here 3 over 14, which is the intersection, then over the condition that the balls are blue. Now this condition has nothing to do with being from bag Y or X. The condition is just that the balls must be blue. So they can be blue from bag X or Y. They can be blue blue from bag X or blue blue from bag what? Y. Usually there is that problem there. So we need to understand that the condition stands alone. Blue blue means it can be from bag X or from bag Y. So all we need to do now is to go and choose blue blue from bag X and then add it to blue blue from bag Y. So blue blue from bag X is 1 over 36 here, and then blue blue from bag Y is 3 over 14. So it means the intersection is 1 over 36 plus, let me just go back here, 3 over 14. 3 over 14, like that. So we add these two and then just use our calculator to find that. So you can easily do that. 3 over 14 plus 1 over 36. So this means I'm doing a probability of 3 over 14 dividing 61 over 252. So all I'm now going to do now is 3 over 14 dividing my answer, which gives me the answer to be 54 over 61. So this is the probability that the two balls are of the same color and they are from bag Y, given they are both blue balls here, like that. So very question in this paper that is from our topics of focus is question number 7. All the other questions are from other topics that I don't think I probed them. So now on permutation and combination is a question number 7. And this question says, how many different arrangements are there of the 9 letters in the word intellect in which the 2 T's are together? So if the 2 T's are together, it means we are reducing the number of characters, if you remember from our class notes. So here, what we just need to do now here is to just put the 2 T's together. So when we have the 2 T's together in the word intellect, this is, and then we block them like that. That's how we did it in class. And then we are going to have I-N, E, and then we've got L-L, E-C, like that. Okay. So these are the only other letters that will remain when we put the 2 T's together. So we now count the characters from there. We've got 1, 2, 3, 4, 5, 6, 7, 8. So it means we've got 8 factorial ways. Okay. Now, because of these 8 factorial ways, how many other letters are repeating? We've got the 2 L's here, they are repeating, and then we've got the E's, they are also repeating. We are going to divide this by 2 factorial times 2 factorial for the repeating E's and the repeating L's, then times how many ways the 2 T's can swap among themselves, which is 2 factorial, but then the T's are repeating as well. We divide by 2 factorial. And if you remember, it is because of this that I said when the grouped items are the same, we don't need to multiply by how many ways they are going to swap among themselves, because it will cancel out with them repeating. But because of conceptual understanding, we must just keep doing that so that we always remember that. So that and that is just 1. And then all we need to do now is to find 8 factorial divided by 2 factorial times 2 factorial. So you just go on your calculator there, shift, you find your factorial, and then you work out the answer. So 8 factorial over 2 factorial times 2 factorial. Okay. So this gives us the answer of 10,080 ways. So this is the answer. So there is 10,080 ways of arranging the 9 letters in the word intellect in which the 2 T's are together. So this is when the 2 T's are together. Now let's look at the second part of the question. Okay, so now in the second part they said how many different arrangements are there of the 9 letters in the word intellect in which there is a T at each end and the 2 E's are not next to each other. Okay, so now here This is a very good question. So we've been told that there is a t at the end. So you can put the t's there, okay? Fixed t's, okay? So these are fixed t's. Remember, at some point we are going to multiply this by 2 factorial ways in which the t's can swap amongst themselves. But again, they are repeating t's, so this will not count. So there is 2 factorial ways in which these t's can swap amongst themselves. This t can be there, that t can be there. But again, because they are repeating, we are going to divide by 2 factorial ways for repeating t's. So this will basically just give us 1. That's why in most books they don't show that. But I love showing it because it helps for conceptual understanding. So take that into consideration. Now, what we know is this, that we are being told that there is what? The 2 e's are not next to each other. So for us to do that, we must assume that the 2 e's are actually next to each other. So we are going to put the e's together and block them like that. The 2 t's are already fixed, so we do not have a problem with those t's. They are already fixed. They've got a position, so we don't need to worry about them. So now in the word intellect, what else do we have if we remove the 2 e's and then the t's? So we are going to have I, N, and then I don't know what else we are going to have there, and then the 2 L's. Is there anything? And the C. Okay, like that. So these are the only letters we are going to have. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. So now we must count these as 1, 2, 3, 4, 5, and 6. This is when we assume that the two e's are together. So what we're going to do now, it's like we've got 6 factorial ways, and then we are going to divide this by the repeating l's, which is 2 l's, 2 factorial, times the e's can swap amongst themselves, 2 factorial, but then since they are repeating, times 2 factorial. This is just for these guys on the middle. Again, that will give us 1, and we just need to work out. So this is when the e's are together. E's are together. So we need to take note of that. So when e's are together and there is a t at both ends, with t at both ends. Okay, so now what we just need to do is to do 6 factorial and then that divided by 2 factorial. Okay, so what this is going to give us, 360. This is when the e's are together and there is a t at both ends. Okay, now remember the question says when the t's are not next to each other. So this is when they are next to each other. So what we need now to do is very simple. Okay, so now we've found ways in which the e's are together and the t's are at both ends. Okay, so now what we need to do now next is to find the number of ways where the t's are at both ends with no restrictions, and then from there we are going to subtract the number of ways in which the t's are at both ends with e's being together. That means what we are going to get is the number of ways when the e's are not together with t's at both ends. So what we are now going to do now in the next one is t's at both ends, okay, and then the e's are just normal. So we just have now a situation with this. Okay, INLLC. So now this is when the t's are at both ends. Okay, and then there are no any other restrictions. Remember in the first part here we looked at when the t's are at both ends and the e's are next to each other, which gave us 360. So you've got to keep that. So now here we are going to say, because we've got fixed positions for the t's, Our only concern is the remaining characters. So here we've got 7 characters. Of the 7 characters, remember, have got 2 E's that are repeating, and then 2 L's that are repeating like that. And then I should multiply this by how many ways the T's can swap amongst themselves, which is 2 factorial. But then since they are repeating, again divided by 2 factorial. If I put this on my calculator, what I'm going to have is 7 factorial, okay, shift, then divided by 2 factorial times 2 factorial, like that. What I'm getting here is 1260. Now, this 1260 is the number of ways, the total number of ways in which the T's are at both ends of the arrangement, including the number of ways in which the E's are next to each other, which is 360. So if we want now to find the number of ways in which the E's are not next to each other and the T's are at both ends, then we must subtract the 2, which is 1260 minus 360. So minus 360. So this gives us 900. So meaning there is 900 ways in which the T's are going to be at both ends and the E's are not next to each other. So this was a very nice question and I liked it. I also like the concepts that we've reviewed. Okay, even here, I like this concept and that concept there. So for you to answer a question where certain characters are not next to each other, you must first you must assume that they are next to each other. You find that number of arrangements, then find the total number of arrangements, then subtract the 2. That's the only way that is possible, and that I find very easy. Of course, there are other methods that could be better, but this is what I prefer to use. Okay. Now let's go to the next bit of the question. Okay. From the word selected or choose, remember, this is now a combination question. A random from the word, 9 letters in the word intellect. Find the percentage. Now, percentage is simply probability, okay, of possible selections which contain at least one E. The word is at least. At least means less, so it means greater or equal to. So greater or equal to 1 E, meaning we can have 1 E, 2 E's, depending on how many E's we have, and exactly 1 T. Okay, and we're selecting what? 4 letters. So let me write this. We are selecting 4 letters. Okay. And in the 4 letters, there must be exactly 1 T. Okay. And at least 1 E. So the first part, we can, there's always going to be 1 T, but there could be 1 E, meaning there will be 2 spaces left to choose from. Then the second part, we can have 1 T, 2 E's, like that. Okay, which means we will be choosing just, for other letters, we'll be just filling up 1 space. Okay, so remember, we've been told that at least 1 E and exactly 1 T. All right, which is fine. So now what we need to do now is to separate these conditions. So we've got the 2 E's like that. Okay, and then we've got the 2 T's. So I'm going to write it here. Let me just write that nicely. Okay, so this was meant to be 4 letters, so I don't confuse you. So we've got 4 letters that we're choosing. Okay, 4 letters. And then we've got 2 T's like that. Okay. And then everything else other than these 2 characters. So we've got the I, the N, the L, and the C, the 5 letters. So here we've got 5 letters, 2 E's, and then 2 T's. Okay. So now, since this is on choose, remember, we are talking about probability. Probability. So first of all, we need to know the total number of desired outcomes. So we've got 9 letters. So you remember, probability is the number of desired outcomes over the total possibilities. So the total possibilities, before we even go any further, total possibilities, okay, with no restrictions, is simply equal to choosing 4 letters out of 9, okay, which is the total sample space. So 9 shift, then you choose 4 letters, no restrictions. We've got 126. So 126 is the number of ways, the total number of ways of choosing 4 letters from the word internet. Now we want to find the probability of choosing 4 letters where there is exactly 1 T and at least 1 E. Okay, so here let's just go into this and look at what we are doing here. Okay, so where we are choosing 1 T, where we've got exactly 1 T, that means we are doing a 2 choose 1 times where we've got 1 E. Out of 2 E's, we are doing a 2 choose 1. Then times, we've got 2 spaces here, these 2 spaces here, to be filled up by any other letter from the 5. So that is going to be, out of the 5, we choose 2, whatever that is going to give us. So 2 choose 1 is 2, 2. So we are just going to do a 5 choose 2 times 4, which gives us 40. So this gives us 40. Then here, where we've got 1 T, again, remember, we are choosing 1 T out of 2 T's. 2 choose 1 times, now in this case, we've got 2 E's, which is just one way. There's just one way of choosing 2 E's out of 2 E's. But if you want, you can say 2 choose 2, okay, times. Now, in this case, now, out of the 5 letters, we only want to choose 1 letter to fill up the 4th space, which is 5 choose 1. Okay. Now 5 choose 1 is 5, 1, and this is 2. So we can actually just go ahead and confirm that, times 2 choose 2, okay, times 2 choose 1, which is just 2. So this is 10 here. Okay. So now, meaning the total number of ways of choosing 4 letters in which there is exactly 1 T and at least 1 E is 126 times 100. Okay, so 50 divided by 126 times 100, which gives me 39.68, which we can say is just 39.7%. Very, very important. So something to remember, percentage is more like some probability. So this is how we come about here. And remember that probability is total number of possible outcomes. The total number of possible outcomes is 9 choose 4. And then we look at the desired outcomes, which is this, which we just expanded. So guys, this is a revision video on the 3 topics that we chose, which is binomial and geometric distribution. Then we looked at feather probability and permutation and combination. Please look out for the next revision video that focuses on other parts of the paper. And we are going to look at variant number 2 in 2024, October, November, and still just be looking at these 3 topics, binomial distribution and geometric, because they confuse people quite a lot. And then we'll be looking at feather probability and as well as permutation and combinations. There's a reason why I choose these topics, because these are the topics where sometimes you students get confused. So the more we practice, the better we get. So please, you can like this video, share it with your friends from wherever, whichever other schools, that's fine. Otherwise, I'm happy. Thank you very much.